Hello everybody and welcome to my lab. My name's Scott Card and today I have for you the first in a series of videos on Proteus. This is going to be a very basic introduction. We're going to create a new project. We're going to create a small schematic, do a little bit of simulation, and lay out a single part on our PCB and call it good enough. Hang around to the end. If you like this video, please give it a thumbs up. If you don't, thumbs down is equally appreciated, but your comments, constructive criticism is always appreciated. It's a great way for me to learn and improve what I'm doing because at the end of the day, it is for you. All right. All right, welcome back. When you first open up Proteus, you should get a home screen that looks very similar to this. Across the top, the first thing that I want to point out to you is this little drop-down menu here. We've got a series of buttons across the top, and the first one will create a new project. The next one is to open a project. This is where we would save our file, and this is exit. This is the home screen, so you can always come back here, and we can always just create a simple schematic or PCB layout here across with these two buttons. And we're not going to worry about the rest of them for right now, but know that if you ever accidentally close one of your screens, for example, if we close this guy, you could create or go back to open it up again. So if you're working in your schematic and you accidentally hit the X, don't worry, it's not gone away. You can always just reopen the schematic. All right. And so the next thing that we're going to do is under our start menu, instead of opening a file, we're going to create a new project. And so I'm going to click on here, and you'll notice that it opens up our wizard. And our wizard's great because it's going to walk us through step by step each process. And so the first thing that we're going to want to do is you're going to want to create a file location somewhere, someplace where you're going to be able to find your files, and you should organize them in a logical way. For me, I've created a file folder already called demo, and so I'll select that as my directory, and we'll create a new file. And for me, I'm going to create a new one called demo1. All right, and yes, I'll replace the existing one. And here we are. So we have some formats that are already available to us, and I really like using these when we're first starting out, before we learn to make our own template. And I will walk you through that in a later video. But for right now, the one that I want you to choose is USA. So that's going to be an ANSI A size paper, so 8.5 by 11, and we want it in landscape mode. And I'll say next. And we also want to create a PCB layout, and default for now is fine. But we're not going to worry about the PCB stack up layer or the drill pairs or the vias, and we're not going to create any firmware. But we will check that our wizard summary is accurate. So we have a file location, a file name, a schematic, a layout, and no firmware. And so we'll finish. And the first thing that it takes us to is our PCB layout. And so this is just, it's generic right now, it's blank. We're not going to worry about it at all. And the next thing is that we're going to click on our schematic. And so, as I said before, if you accidentally close this, don't worry, it's not gone. You can always go back to your schematic capture and it will reopen your schematic. And okay, so as you can see, we have an 8.5 by 11 piece of paper with a beautiful border and a perfect title block with fillable fields. And we're not going to worry about filling these in just now. Just note that the file name does follow your file name, and the date is updated as well. And we're not going to worry about anything else with that today. All of our drawing is going to take place over here on the left hand side. So this is today our selection mode and our component mode and our terminal mode. These are the three buttons that we're going to need today. And so the first thing that we're going to do is we're going to want to select some parts. And so I'm going to go under my component mode, and I'm going to pick some parts. And the first part that I think we're going to want is a resistor. And so I'm going to scroll down here till I see resistors, and I'm going to scroll down under my subcategory to a generic resistor. And you can pick one. Mine happens to be the squiggly line. If you have the rectangle, it's fine. They both react the same. And so I just double click on it, and you'll notice that it drops it over my devices. The other way that we can get some components is we can actually just start typing them in. So in this case, let's pick a capacitor. And so there we go. I start to type cap, and we can see that the categories list got very small quickly. So there's a capacitor, and we'll pick something animated because, well, we're going to create a simulation, and the animated capacitors, they just kind of look cool. So we'll double click on that. What else do we need? How about a button? So I'm actually going to fully type in button, and notice that it really tapers down what's available to us. And so in this case, we actually want a button. One thing that you do want to make sure when we're picking these parts, if we're going to simulate it, is you want to show only parts with models. Okay, and we'll get into why that is in a subsequent video, but make sure that the components that you pick today do have models. Okay, so we've got a capacitor, we've got a button, we've got a resistor, and everybody's first project has to have an LED. So let's pick an LED, and you'll notice that there's a lot of different options here. And so let's go in, and we're going to pick optoelectronics. We're going to pick LEDs under subcategory, and we want to make sure that we pick something that's active. Okay, so you can pick an orange or a blue or green or whatever color you want. It doesn't matter. I'm going to pick orange today just because. And you'll notice that if you press enter when you're selecting these items, it will still select the item, but it will close that menu down. So the double clicking is a great way to prevent having to go back in and pick another part. All right, and so now that we have some components on here, we can actually start to lay them out. And when we go to lay a part on, I see a lot of people, they always double click, and it opens up this menu. You don't need to double click and open up the pick menu. You just need to highlight it. So just click once, and then click on your page once to sort of import it, if you would, and then the second time you click it, it'll place it. And so there's my button, and then I can drop a couple capacitors in here like so, and then we're going to want an LED, and we know that we want to reduce some of the voltage going into this LED, so we want to limit the current, and so I'll pick a resistor and drop it in here as well. And this is a great start. This is fantastic. This is, everybody's dream first project, right? You've got a capacitor, a resistor, and an LED, and we're going to make it turn on. And so how do we wire it? How do we make it fit together? And so you'll notice that my little pencil here, when I hover over one of the endpoints, one of the terminals, it turns green, and it highlights the node. And so if I left click, I can pick a beginning and an end point. And so how do I join this connector to this terminal up, or to this wire up here? Well, again, I can select a terminal and come up and then click on the wire. And because I'm as pragmatic as I am, I don't want to have to click too many times. And so this time I'm just going to double click on this end terminal. And you'll notice that it drops a wire that's exactly the same size as the last one. Here it doesn't do me a lot of good because I would actually need to then connect it across. All right. And so here we are. We've got a few lines, laid in here, and let's wire this up. We need to actually start to connect this to something, right? And so here we go. We've got our negatives hooked up, and so I promised you that we were going to do something under terminals mode. In here is where you will find power and ground. All right. And we can connect them to our system as well. Now, one thing to note is how to delete things. So there's a couple ways that we can do this. One is you can highlight it, right click, and then say delete. You can highlight it and press the delete key, or you can also just simply double right click on a component. So there's lots and lots of ways to get rid of components. I wish they were as easy to place. All right. So here we are. We've got our components laid in, and now we need to start to do some design work. So what is the voltage drop of this LED? If you double left click on it, you'll notice that it opens up the Edit Component menu. And in here, there's some very important information. For example, the forward current at 20 milliamps is 2.2 volts. And that the full drive current, so it'll turn on, it's at full brightness at 10 milliamps. And so we can ignore that for right now. And this is the important information that we want. We also want to make sure that this is set up as an analog device. What digital will do is it will basically draw no current and just turn on when there's a voltage present. And that's great if you're using it for a digital indicator, but not so great if you're trying to simulate an analog circuit. So we want to make sure that that's on analog. We'll say OK. And so now we need to limit the current going into this because it only draws 2.2 volts. And so if using Kirchhoff's voltage law, if I have 2.2 volts here and I know that my input is 5 volts, then I need to use this resistor to limit the current and drop that extra voltage. And so in this case, my 5 volts minus 2.2 means that I am dropping 2.8 volts, and Kirchhoff's current law says there's 20 milliamps going through here. And so we can use Ohm's law to say 2.8 volts divided by 20 milliamps requires this resistor to be 140 ohms. And so a couple ways that we can change this. One is we could go into our edit properties here, and we could type it in, or you could actually just type it into here, into this label. So 140 ohms. And then we can actually run a little simulation on this. So here we go. So we have no charge in our capacitors, and we have no LED come on until we press the button. And sure enough, we press the button and the LED comes on. But note that the capacitors, they don't really look like they're fully charged. So why don't we stop our simulation? And we're going to go in here and we're going to take a look at what's going on. And so we have 1,000 microfarads. But it says that our working voltage is 12 volts. Well, it's only ever going to go up to 5. And so we want it to show 5 volts as fully charged. So we'll say OK. And we could do the same over here. We could copy that. But instead, I'm going to double right click and get rid of that. And what I'm going to do is I'm going to highlight this part. And I'm going to use the block copy. And I'm going to copy this over. The reason I want to do this is it actually brings over all of the properties. Now, today it's only one thing that we've changed, and it's not a big deal. But if we had set it all up that there was something specific about it, so there's a footprint associated, there's a bill of materials and a price that's associated, you may want to actually bring that over and with all of the assets attached. Okay, so the next thing that we want to do is turn this from a pretty simulation to an actual design tool. And the way we're going to do that is here under probe mode. We're going to go in and monitor, say, the voltage here and possibly the current here. Now, the one thing that we want to be really cautious of is with the current that the arrow is pointing in the direction of the current flow. So not the electron flow, so positive to negative. All right. And so the great way to do that is to rotate it. And when we were laying the parts out, I didn't really need to, but the plus and the minus is a great way to rotate your part around as opposed to laying it and then rotating it. It's a bit of a pain to do it that way. All right, so now we're able to monitor the voltage and the current. So now when we run our simulation, we can see with the open circuit, we don't have any real voltage and we don't have any real current. And I'll click on the little icon here, which will actually lock the button in the closed position. And now we can see that our capacitor C1 and capacitor C2 are fully charged. And we're sitting just 2 millivolts below peak. And that's because there is a little bit of resistance here in our button. And we're drawing pretty close to 20 milliamps. We're 400 microamps too low. And so that's good enough. And so now if I click on the button, it opens up and we can see the voltage dissipating as the current goes through the LED and sinks down. And we shouldn't see it go too much further down. And the reason being is there is a breakdown voltage here on the diode. And so this is fantastic. This is telling us exactly what we would see in real life. Just the bleed through current will continue for a while, and perhaps eventually it would reach 0. But press it again and the LED again brightens up and then dims down. So fantastic. We can stop this, and if we go over to our PCB layout, the reason why we're not going to worry too much about this is you notice that there's these X's on each of these, and if we tried to lay one of the parts in, it would say that there isn't a footprint associated. So we're not going to worry about that too awfully much. But if we did have components, and for example R1 here, we could lay in a component. And so that's fantastic. That's going to be a topic of another video, but this is how we would start to do our PCB layout. But that's for another day. For right now, we'll call this finished, and I'm happy with my simulation. I'm happy with my layout, and a great start. Okay, if you like this video, please give it a thumbs up. If you didn't, you know what to do. Comment away, and do subscribe if you want to be kept abreast of new videos that I post, especially with this topic. I plan on outputting quite a few short little videos like this. I do apologize, there's not a whole lot of post editing. The idea is to just get the information out there and let you consume it. All right, thanks, and have yourself a great day. Bye now.